last example in 9.3 for Math 20-1. It's another word problem, but it's a much simpler one, I would argue. It's talking about the mass and the diameter of the rope. And one of the things that students struggle with in equations like this or questions like this is there's no y and x. So we get to arbitrarily choose, and I say arbitrarily, but it's not going to be arbitrary. We're going to choose y as the isolated variable. So I'm just going to say that m is going to be represented by y, and d is going to be represented by x. And the reason why it is valuable to put that in terms of y and x is really what this question is trying to get us to do is graph y is less than or equal to 1,450 times x squared. Now, before we kind of get too far into the equation, we have to try to remember what we're representing with y and x. Because m represents mass, the mass on this rope must be positive, right? There's no such thing as negative mass. So because m is greater than or equal to 0, I'm going to write underneath it that y has to be greater than or equal to 0. Now, I do want to identify that really what that means is that nothing in quadrants 3 or 4 is valid for this question. We cannot have negative mass. D is the diameter of the rope. In order for there to be a rope, the diameter must exist, so D has to be greater than or equal to 0. Now, if we talk about what that looks like graphically, then nothing in quadrant 2 or quadrant 3 or, and I'm going to actually draw this one, x is greater than 0 there, it would be this dotted line and everything to the right of it. Everything in that red region is where x is less than 0. Now that I've done that, I'm actually going to do it for my y inequality as well. That would be this solid line and everything above it. Now, if we think about those two restrictions together, what we can really do to make this a little bit easier is those two things combined means that only quadrant 1 is valid. And that's the best way of doing this question. You could certainly write those out, and you should write those out. But once we've identified that, now all we have to do is to make sure we understand that really what that tells me is that I have to make sure that I'm only graphing my function in quadrant 1. So I'm going to make kind of a nice big graph here. And then what we're going to do is we're going to plot a few points. And it is one of those things that we know this is a quadratic that opens up. It opens up quite quickly because it's, 1,450. But to try to make this a little bit simpler to visualize, what I'm going to do is I'm going to draw y equals just kind of a parabola. And then I'm going to find a few points on it, just so we have some idea of the scale of this. Well, this point down here would be 0, 0. If there is no rope, it can't support a human being. This point right here is going to be at 1, 1450. So if my rope has a diameter of 1 inch, it can hold 1,450. So I just lost the mass unit there. Just want to see what it is. It's in pounds. So imperial for today. So if we have a rope that has a diameter of 1 inch, it can hold 1,450 pounds. And then what's going to happen is that this is just going to keep going up and up and up. I'm only going to grab one more point here. If I take 2 and square it, then multiply it by 1450, I get that this point right here, and I'll try to make the x roughly equal right here. This point is going to be at 2, 5,800. So a 2-inch diameter rope is going to be able to support 5,800 pounds. All right, after we've identified a few points and drawn our parabola correctly, we have to decide if we're going to shade in above or below it. Well, because y is less than or equal to 1,450x, we do shade below it. I always think it's a good thing to confirm. If this point right here is at 1, 1450, then I'm going to pick a point that I know is directly below it, which would be 1, and just arbitrarily, I'm going to choose 10. Right, that has to be below it because I've lowered the y value but kept the x value the same. So to check if I was right with the shade in below it concept, I'm going to test 1, 10 in my equation. So is 10 less than or equal to 1,450 times 1 squared? We get that 10 is less than or equal to 1,450. That is correct. That means we shade in below the region. Now, before I get too kind of shade happy, I would like to do that. What we are really going to do is make sure that we dot that line, because we have to make sure. Oh, I dotted the wrong line there. My bad. I dotted the y is greater than or equal to 0 line. It's actually this dotted line, and I'm just going to draw everything to the right of it. And it's this solid green line, everything above it. And I'm going to put what inequalities I'm drawing there. That would be y is greater than or equal to 0. And what I did in blue over here would be that x is greater than 0. Notice the difference. Solid green line, dotted blue line. That's a very, very important distinction. Last thing I'm going to do then is I would shade in the overlap of all of these regions, and it would end up being this shaded location. And certainly this red line keeps on going. And I'll just shade to that point. Now, this is a pretty useful concept because if I know how much I'm lifting with the rope, I can use this to determine if, I have a large enough rope. If I know how much I want to lift, what I could do is I could determine, if nothing else, the minimum diameter of rope required, which might save me money because typically larger diameter ropes cost more money. So a pretty interesting application of inequalities in everyday life. Most of your problems are going to be more solved quadratic inequalities presented to you, but it's really important that if you are solving multiple inequalities, it is the overlap of the regions of each inequality. All right, I'm going to put up the standard assignment. Make sure you are checking Google Classroom for that modified assignment. We are going to be checking the homework for chapter 8 and 9 very soon here. Make sure you're staying caught up because it does make things a lot easier if you're in the same pace that we are going. All right, good luck. Email if you have questions, please.